Hello, good morning. So coming to our project, this is a telecom churn prediction, and we had uh, included our link also in the kaggle.com. And coming to contents, we covered almost everything coming from problem statement, goal, data dictionary, everything like handle outliers, feature scalings, modeling, building, conclusion. So we can get everything this. And coming to problem statement, customer behave during churn usually doesn't happen at all once rather. So procedure is especially important for valuable clients and their alternative and their concluding. So good phase is customers display typical use habits and typical happy with services they receive during the initial phase. So after sometimes they're unhappy and looking for alternatives. So this creates the problem for the primary carrier. So here, the coming to problem, the few things might make them less satisfied or loyalty is the trigger might be getting allerging offers from business and increasing more cost effective. So the churn phase is last step before client choose go to rival and stop using the service and switch to alternative services. So coming to next slide. So the goal is like to provide an overview of how to write a notebook and create submission file that successfully solves the churn prediction problems. So we're going to following the process called CRISP DM, and we want to prepare data for the modeling. So we can see here the dependencies and data sets at the right side. So so we can start the dependencies loading and we can keep adding any imports uh, for this cell block and write mode and mode code. And we can see the data sets below, like it will read the data from data set from first Excel and it will load into data dictionary. So coming to the data frames containing rows, and we can see the more data sets and columns. So the data frame contains 36 rows total and two columns like providing description to data variables. So data dictionary, the churn data set. So this is the churn data set, like it is a list of abbreviations that clarify the meaning of specific variables in the churn data set. So we used like onet mu6 denotes minutes of usage for voice calls within same operator, and night peak user rate signified the usage of scheme during night time, and max reach data 7 refers to maximum mobile internet. So these are the just abbreviations, and we used small meanings for it. And by taking notes on potential impacts, features, and conducting through analysis, such as exploring statistical distributions, correlations, trends, we can again value insights into factors. So coming to next, it is an column names for data frames. So in right side, we can see we have declared some variables, we have declared some IDs, and we gave some volume and data set into the volume. So the IDs and total amounts, total ongoing minutes, and the churn probability, the target variable indicates like churn. Those script then combines lists into single flat is called variables, including all columns and target variables. Finally, it subsets the data frame to include the column list and variables, IDs, index, etc. So the process prepares the data by selecting relevant features for the further analysis. Though coming to the next one, it provide data snippet represent subsets of customer level data, and we can see the columns in the right side like circle ID, a total reach amount, total recharge amount of months, and etc. So these are the data sets we contain in our churn data. So next slide will continue by my friend.
Thank you, Raman. Hello, everyone. So, coming to the each variables data type that we have used here, it comprises of many entries, almost 69,000 entries and 24 columns, as mentioned over here. Mostly they are with non-null values. So data types includes integers and features like circle ID and total reach amount. That in the sense, how much amount we are reaching over to, and churn probability, like how is the ratio of the customers that are leaving, and floats for the columns related to call usage, revenue, and data volume. So some columns such as offnet mo, that means it represents a minute of usage for voice calls, and RPU means average revenue per user. So it contains missing values indicating potential data gaps. The data frame that you have mentioned over here, it shows the approximately 13.4 MB of memory representing telecom related features for customer behavior and analysis, and also for the churn prediction. So the statistical summary that are presented over here provides insights into data distribution, central tendency, variability, and churn probability distribution. So the next slide also indicates, it also shows the data types only. So data sets includes variables such as total that means minutes of usage for voice calls, and there are 6 and 7 versions. They are likely representing some measures of usage for activity. So the histogram that is presented over here, it reveals that the minute of usage per for voice call for 7 has higher frequency in lower range compared to the sixth one, so it indicating potential differences in usage patterns over time. Another variable with the reach amount of 8, it is likely depicting distribution of recharge amounts. So the histogram that is shown over here that shows lower recharge amounts are more frequent, gradually decreasing as the amount increases. While coming to the next slide, here it indicates the heat map. The provided heat map in the picture that illustrates the percentage of missing values in the churn data set across different columns and time periods. Moreover, each row that is depicted over here, it represents a specific feature, while each column that corresponds to a different month. So for example, when analyzing the total reach amount, columns 6 and 7 and 8, we find no missing values in the month of June, but 1% missing values in the month of July, as mentioned over here with the color graph, and 1.59% missing values in the August. Similarly, the heat map that displays over here, it represents missing value percentages for other features such as total minute of usage for voice call, and off-net means outgoing minutes of other networks. RPU means average revenue per user, and average revenue per user for 3G and 2G services, and also for volume of 3G and 2G mobile data usage. So for the next slide, the data, the split, we have a test split here. So the provided code snippet, it first identifies the unique value in the circle ID column, revealing only one unique value, that is 109, suggesting there's likely only one unique circle in the data set. So it then creates a feature matrix X by excluding the circle ID column from the data set, assuming it's not relevant for analysis. So while going to the next slide, we have handling some missing data over here. So the bar graph that is displayed over here, it counts the non-null values for selected columns in the dataset. Features such as total reach amount 6, 7, or 8, whatever it may be, and total minutes of usage 6, 7, or 8 have the highest number of non-null values indicating data availability. So this, however, columns like RPU, average revenue per user, and volume show fewer non-null entries, suggesting potential data gaps over here. And while coming to the next slide, we have the calculated the missing data for each column here. Um, so here, the missing data from each column, such as OffNet, Mo, RPU, and RP2G or 3G, whatever it may be, it shows varying percentages of missing data ranging around 3.83% and high as 74%. So this highlights the importance of handling missing values approximately during data preprocessing. And in the next slide also, the this also comes under the missing data for each column only. So we have dropped columns with more than 40% missing data to ensure the integrity of our data set for each churn prediction. Moreover, the new variables contains a subset of columns selected based on the percentage of missing data being less than or equal to 40% over here. And these variables have relatively low levels of missing data, making them suitable for further analysis or modeling tasks without significant data imputation or handling. So welcome to the histogram that is presented over here with kernel density estimates. So for numerical features, it provides insights into the distribution of values across different variables. So each variables that we have discussed earlier, so they are represented on the x-axis, while the frequency or count of occurrences are represented on the y-axis. So this visualization helps understand to spread and density of values for each variable, offering a comprehensive overthink of distributions and potential insights into the relationships so with each other and the target variable churn probability. Thank you. And the next slide will be continued by my friend. Thank you.
Thank you, Datri. I'm going to explain about correlation heat map. This visualization represents the correlation coefficients between various variables such as recharge amounts for different months, total minutes of usage, and data volumes over 2G and 3G networks. High correlations are indicated by colors close to red +1 and blue -1, showing strong positive and negative correlations respectively, while shades of white represents no correlation, that means zero. uh, Next slide, I'm going to explain about box plot of total recharge amount versus churn probability. This box plot compares the distribution of total recharge amounts between customers who churned and those who did not. It's useful for determining if recharge amount is a significant predator of churn. The presence of outliners is also depicted, which may indicate extreme but relevant customers' behaviors or data errors. Scatter matrix of selected numerical features. It displays pairwise relationships among several key variables like total recharge amounts, total incoming and outgoing minutes, and off-net minutes. Each plot helps in identifying trends or patterns, which could be linear or non-linear. And the density of points can indicate the range of typical behavior versus anomalies. Next slide. I'm going to explain about imputation on variables. The slide addresses the challenges of missing data in a data set and outline strategies for imputation, which is the process of replacing missing data with substituted values. Common imputation techniques are mentioned, including replacing missing values with constants like zero, the mean or median of the column, or using more advanced methods such as interpolation or multiple imputation by chained equations, which is mice. The example shows utilizes simple imputer from skitlen to fill missing values with zeros, specifically targeting columns of net uh, minutes 6 and off-net minutes 7 and off-net minutes 8, which presumably deal with off-net minutes usage across different months. Next slide, I'm going to explain about visualizing data completeness. This image showcases a bar graph displaying the count of non-null values across various columns in the data set. The graph is helpful to visually access the completeness of the data, revealing which features are fully populated and which may contain missing values. This helps in deciding the priority and method for data imputation. Columns like total reach amount and total uh, minutes and churn probability appear to have complete data, whereas other columns might have varying degrees of missingness. Next slide. I'm going to explain about the described method provide statistical summaries for the columns of X-trained filter. Here are some key insights. For columns like total recharge amounts and total outgoing call minutes and 3G mobile data volume, the count shows that there are 55,999 entries with non-null values, indicating no missing data in these columns. Standard deviations reflect the spread or variability in the data, with larger standard deviations suggesting greater variability from the mean. Minimum and maximum values show the range of values present in each column, providing context on the magnitude of the data. And the churn probability column with a mean of approximately 0.1025 indicates a low overall churn rate, as expected in telecom datasets where churn is typically minor class. Next slide. I'm going to explain about exploratory data analysis and pre-processing. The above graph includes the related to recharge amounts and total incoming and outgoing call minutes, off network call minutes, and mobile data usage, and volume. The churn probability column likely represents the probability or likelihood of a customer churning. The values I and do 200 seem like anomalies or errors in the data. Overall, these columns provide insights into customer behavior and usage patterns, which can be visible for churn prediction and customer retention strategies in the telecom industries. Thank you. Next slide, my friend is going to explain.
Thank you, Tejasri. Here I'm going to ask a few questions. Is there any correlation between a total recharge amount and total outgoing minutes? We all have a doubts on this. So I'm going to explain about this. The scatter plot visualizes the relationship between total recharge amount and total outgoing minutes. Each point on the plot represents a data entry from the dataset and where the x coordinate corresponds to the total recharge amount, which likely indicates some kind of total minutes of usage, and y coordinate represents the which likes to indicates the total recharge amount during a specific period. And the second question is, how does the average revenue per user in 2Z vary over time and across different circles? The line plot visualizes the trend of average revenue per user for 2G services across the different circle IDs over the months of June, July, and August. Each line represents the uh, average revenue per user values for a specific month, with the x-axis indicating the circle ID and the y-axis representing the average revenue per user value. The plot allows us to observe any variations or patterns in average revenue per user for 2G services across different circles over the specific time period. And the third question is, what is the distribution of the volume usage for the 3G data compared to 2G data? The box plot visualizes the distribution of the volume usage in megabytes for 3G and 2G across the months of the June, July, and August. The box plot provides a clear representation of a central tendency, spread, and potential outliers in the data. Each box plot section corresponds to a specific type of your data usage in a particular month, allowing for easy comparison between them. Overall, this visualization aids in understanding the distribution and variability of volume usage for both 3G and 2G data over the specific months. And the fourth question is, how does the churn probability vary with the different levels of off-net minutes? The scatter plot illustrate the relationship between off-net minutes across the three different months, June, July, and August. Each point on the scatter plot represents a combination of your off-net minutes on churn probability for a specific month. If there is no clear trend or correlation, it suggests that off-net usage might not significantly influence churn probability. And the last question is, can we identify any trends in the total recharge amount based on the tenure of customers? The line plot depicts the relationship between the tenure and total recharge amount for the three different months, June, July, and August. Each line on the plot represents the trend of total recharge amount over tenure for a specific month. The plot helps to visualize if there is any, uh, sorry, give me a second. Yeah, it indicates that as the tenure of your customers increases, the total recharge amount also trends to increase. This visualization can provide insights into how customer spending behavior changes over the duration of being on the network. And coming to handling outliers, this function outliers is designed to limit outliers is an in an array. It calculates the upper and lower limits based on the array's mean and standard deviation multiplied by a factor k. Any values in the array below the lower limit are set to a lower limit, and the values above the upper limit are set to be to the upper limit. This process helps mitigate the impact of extreme values on statistically analysis or models. The plot shows box plots for various features in the filtered training data. Each box plot represents the distribution of the values per a specific feature, with the box indicating the interquartile range. The line inside the box representing the median, and the whisker showing the range of the data within 1 point times of interquartile range. Thank you. My friend will continue on the next slide.
Thank you, Chana. So I'll be continuing with feature scaling. So these numbers and labels that are seen like rankings or scores for different features. For instance, total reach amount 6 has a score of 5, indicating it might be the most important feature, while churn probability has a score of 1. So we can perform feature transformations at these stages. Positively skewed, common transformations of this data is included within the square foot. And negatively skewed, it includes between square, cube root, and logarithm. Next slide, please. Next slide. Yeah, so next is correlation matrix. In this, typically, they're represented with the actual classes or labels, while columns represent predicted classes or labels. And the overall structure suggests an evaluation of the model's performance in predicting certain features or outcomes. Next slide. Distribution of the churn probability. So this historic plot likely represents the distribution of variable, possibly churn probability. And the y-axis likely represents the churn probability values ranging from 0.0 to 1.0. And the y-axis represents the counter frequency of occurrence. And the plot indicates the large number of data sets into the churn probability. And let's go to the next slide. Feature engineering and selection. So random forest classifier with 100 decision trees that will be trained concurrently using all the available CPU scores. So these create a bar plot, and all these steps are created with a bunch of features based on the businesses. And another way of finding good features would be to the project them into the lower dimensional space using PCA. Next slide. And what is PCA, Principal Component Analysis? So these are the linear combinations of the feature that will allow you to select the components which explain the highest amount of the variances. So this visualization here helps us in understanding the distribution of the data points in reduced dimension space and any point clustering or separation between churn and non-churn instances. Can I have the next slide? Yeah, so here the plot is using Seaborn with the second principal component on the X and the Y axis. And also it provides an insight into clustering or separation patterns between churn and non-churn instances in the reduced dimensional space defined by PCA. And next will be continued by Shira. Thank you.
Let's also check which of the following components have high future importances towards the end goal of churn prediction. The provided code initializes a random forest classifier with 100 estimators and utilizes all above CPU cores. It then fits the classifier using the principal components obtained from PCA analysis and the target variable. It generates column labels based on the number of future importances, creates a data frame containing the column labels and corresponding importances, and finally plots a bar graph depicting the importance of each principal component in predicting the target variable. Model building. Model has 89.8% accuracy. Let's build a pipeline to the score model faster. The steps of the pipeline would be the following, but this is only one type of pipeline. Imputation scaling PCA classification model. Pipeline for classification cleaned data. The submission file should contain churn probability values that have to be predicted for the unseen data provided test. The provided data represents the average revenue per user for a specific period. The value ranges from 0 to 700. A finer graduality within a metric APR metric. Next slide. Yeah. Time since dataset possibly indicating dates for time lapse associated with certain events of transactions, for instance, 8/21/2014 and 6/25/2014. Checks it the column churn probability and in data frame unseen and returns false, indicating the column not present at the checks. displays a submit for the data inspection or verification purpose. Next. The column names in the unseen data frame confirming that churn probability is not among the columns. If then verifies this by explicitly checking its churn probability in the columns, which returns false. Additionally, it checks the index name of unseen, which is found to be none. The first few of rows unseen are printed to inspect its numeric columns. Overall, the code performs checks related to the columns names, index name, and column presence in the data frame. Next. Conclusion. From the data snippets provided, we can draw several conclusions regarding the telecom churn problem. The dataset includes information such as average revenue per user across different months, dates related to recharge active, and other optional metrics. The suggest of a time series analysis approach is relevant as customer behavior and churn rates may vary over time to factors like service quality, pricing, and promotional offers. Additionally, the presence of missing values indicate in the heat map highlights the importance of data processing techniques like imputation. Furthermore, the high accuracy achieved by machine learning pipeline on both training and test data underscores the potential effectiveness of predictive models in identifying churn risk factors and implementing targeted in retention strategies. Overall, leveraging historical data and advanced analytic technique can aid in understanding customer churn dynamics and devising progressive measures to mitigate churn and enhance customer retention in the telecom industry. Thank you.